Dear students, welcome to my classroom. In previous parts of progression chapter, we learned about nth term of an arithmetic progression. And also we solved two exercises related to the problems of nth term of an arithmetic progression. And in this class, we are going to learn about sum of n terms of an arithmetic progression. So students, we know that the general form of an arithmetic progression is a comma a plus d comma a plus 2d up to a plus n minus 1 into d, where a is the first term and d is the common difference of the arithmetic progression, where a is first term, a plus d is second term, a plus 2d is third term, and in that way a plus n minus 1 into d is nth term. Okay, and sum of n terms of this AP is denoted by Sn. Sn is nothing but the sum of n terms of the given arithmetic progression. In that way, Sn is equal to a plus d plus a plus 2d up to a plus n minus 1 into d. And the term before a plus n minus 1 into d is a plus n minus 2 into d, which is a n minus 1, n minus 1th term of the progression. And by writing these terms in reverse order, we get Sn is equal to, from last, a plus n minus 1 into d, a plus n minus 2 into d, and before that a plus n minus 3 into d, and the last term is the first term from this row, that is a, and last from second is a plus d, like that. Now, adding these two equations, we get Sn plus Sn is 2Sn. And now, adding first two terms on right side, we get a plus n minus 1 into d. That is 2a plus n minus 1 into d is the first term. And by adding second terms, we get a plus a, 2a plus n minus 2 into d plus 1d, that is n minus 1 into d. And again, we are getting 2a plus n minus 1 into d. And similarly, by adding third terms also, we get 2a plus n minus 1 into d. And the term, the second from last is a plus n minus 2 into d plus a plus d. Again equals to 2a plus n minus 1 into d. And the last term, sum of the last term is also a plus n minus 1 into d. That is 2a plus n minus 1 into d. That is, all the terms are equal to 2a plus n minus 1 into d. In that way, we get Sn plus Sn, 2Sn is equal to 2a plus n minus 1 into d, 2a plus n minus 1 into d, 2a plus n minus 1 into d, up to the last term is also 2a plus n minus 1 into d. And we know that there are n terms in given progression. That is n terms. So, in this sum also we have n brackets, which are the sums of terms in these two rows. That is, we have n 2a plus n minus 1 into d here. So the sum of these 2a plus n minus 1 into d is equal to n into 2a plus n minus 1 into d, because 2a plus n minus 1 into d, 2a plus n minus 1 into d, in that way we have n terms. So the 2Sn is equal to n into 2a plus n minus 1 into d. And from this we can write, by transforming 2 to right side, we can write Sn is equal to n by 2 into 2a plus n minus 1 into d. This is the formula to find the sum of n terms of an arithmetic progression. Using this formula, we can find sum of any number of terms of an AP. If we can find sum of 2 terms, sum of 3 terms, sum of 100 terms, as well as sum of any number of terms. and sum of two terms is written as S2, sum of three terms is written as S3, like that. And Sn denotes the sum of n terms. Okay. Now we have Sn is equal to n by 2 into 2a plus n minus 1 into d. We can write it as n by 2 plus n by 2 into a plus n minus 1. That is, I am splitting 2a as a plus a. So we can write it as n by 2 into a plus n minus 1 into d. And students, we know that a plus n minus 1 into d is the nth term, that is the last term of this progression. So we can write it as Sn is equal to n by 2 into a plus, and a plus n minus 1 into d is the nth term, that is an. But here we have only n terms, so that an is the last term. So we can write it as Sn is equal to n by 2 into a plus l, where l is the last term of arithmetic progression. So we can use this formula also when the last term is available in given arithmetic progression. Okay, so whenever the last term is available and we know the number of terms and first term, we can use this formula, which is better than to use this long formula. Okay, and now we have Sn is equal to sum of n terms, that is a1 plus a2 plus a3 up to an. And before an we have n minus 1th term, that is an minus 1. And as we know, Sn is equal to sum of n terms, then sum of this Sn minus 1 terms, sum of this n minus 1 terms is denoted by Sn minus 1. Okay, as Sn denotes the sum of n terms, then sum of n minus 1 terms denoted by Sn minus 1. So we can write these numbers, sum of these numbers as Sn minus 1. So that we can write Sn is equal to Sn minus 1 plus An. And from this we can write An is equal to, An is equal to Sn minus Sn minus 1. That is, subtracting sum of n minus 1 terms from sum of n terms, we get the nth term of the arithmetic progression. Okay, so An is equal to sum of n terms minus sum of n minus 1 terms. Okay, students. So these are the two important formulae regarding to the exercise that we are going to solve now. So let's start the exercise 6.3. So the first problem is find the sum of the following APs. So here some arithmetic progressions are given. We have to find the sum. First one is 2, 7, 12 up to 10 terms. That is, we have to find the sum of 10 terms in this arithmetic progression. So in this arithmetic progression, we have a is equal to 2. The first term a is equal to 2. Common difference d is equal to, we know, a2 minus a1, that is 7 minus 2, which is equal to 5. And the number of terms given is n is equal to 10. So we know that sum of n terms is Sn is equal to n by 2 into 2a plus n minus 1 into d. And we need here sum of 10 terms. So by substituting n is equal to 10 in this formula, we get the sum of 10 terms, that is S10. So by substituting n is equal to 10, sum of 10 terms is S10 is equal to, we know that n is equal to 10 and a is equal to 2, d is equal to 5. And substituting all these values in this formula, S10 is equal to 10 by 2 into 2 into 2 plus 10 minus 1 into 5. That is 10 by 2 is 5, 2 into 2 is 4, 10 minus 1 is 9 into 5, that is 5 plus 5 into 4 plus 9 5 is 45, and 4 plus 45 is 9, and the sum of 10 terms is 5 into 49, that is 245. Therefore, sum of 10 terms of given progression is 245. So let's take the second one. Minus 37, minus 33, minus 29 up to 12 terms. So in this AP, first term A is equal to minus 37. The common difference D is equal to A2 minus A1, that is minus 33 minus of minus 37. That is minus 33 plus 37, which is equal to 4. And the sum of n terms is Sn is equal to n by 2 into 2a plus n minus 1 into d. Now we have n is equal to 12, a is equal to minus 37, d is equal to 4. And now by substituting all these values in this formula, we get S12 is equal to 12 by 2 into 2 into minus 37 plus 12 minus 1 into d is equal to 4. That is 2 6 we have. So 6 into 2 into minus 37 is minus 74. 12 minus 1 is 11 into 4. That is 6 into minus 74 plus 44, which is equal to minus 30. So 6 into minus 30 is minus 180. So the sum of 12 terms of given AP is minus 180. And similarly, take the third one, 0.6, 1.7, 2.8 up to 100 terms. So just now I'm presenting the problem. Just watch carefully. I'm not explaining here. Just understand yourself. Okay, students, please watch carefully. So sum of 100 terms of this progression, given progression is 5,505. Okay, so let's take the next one. 1 by 15, 1 by 12, 1 by 10 up to 11 terms. So in this progression, first term A is equal to 1 by 15. Common difference D is equal to A2 minus A1, that is 1 by 12 minus 1 by 15. And we know that the LCM of 12 and 15 is 60. So take 60 as LCM. We know that 12 5s are 60. So 5 1s are 5 and 15 4s are 60. So 4 1s are 4. In that way, we get 1 by 60. So the common difference D is equal to 1 by 60. Now sum of the terms, n terms, is Sn is equal to n by 2 into 2a plus n minus 1 into d. So that sum of 11 terms is 11 by 2 into 2 into a, that is 1 by 15 plus n is 11, 11 minus 1, d is equal to 1 by 60. So 2 into 1 by 15 is 2 by 15, and 11 minus 1 is 10, and we can divide 60 by 10, 10 6 are. So we remains with 1 by 6. So 11 by 2 into 2 by 15 plus 1 by 6. And LCM of 15 and 6 is 30. So 15 2s are 30. So 2 2s are 4. 6 5s are 30. So 5 1s are 5. So we have 11 by 2 into 9 by 30, which is equal to 33 by 20. So the number of sum of 11 terms in given arithmetic progression is 33 by 20. Okay. So take the second problem. Find the sums given below. So under this title, the first question is 7, 10 and a half, 14 up to 84. Here the number of terms is not given, but the last term of the progression is given. Let us see how to find the sum of this progression. Okay, as we can see that the common difference throughout the sequence is same. Given progression is arithmetic progression. Now the first term of the given progression is A is equal to 7, and the common difference D is equal to A2 minus A1, that is 10.5 minus 7, which is equal to 2.5, sorry, 3.5, and is equal to 7 by 2. Okay. So students, we know that the formula to find the sum of n terms of an arithmetic progression, we have two formulae, n by 2 into 2a plus n minus 1 into d, and another one is n by 2 into a plus l, and n by 2 into a plus l is suitable when we know the last term of given progression. So that here the suitable formula is n by 2 into a plus l. We can find with the first formula also, that is n by 2 into 2a plus n minus 1 into d. So we can use two formula here, but it is very easy to use second one, I think. Okay. But here we don't know the number of terms in this progression. That is, we don't know the value of n. That is, we don't know the number of terms in this progression. So let us find the number of terms in this progression. Let the number of terms in given AP be n. As there are n terms in given progression, the last term 84 is the nth term. Okay. So nth term of given AP is 84. That is, an is equal to 84. And we know that an is a plus n minus 1 into d. So writing that formula, and by substituting the values of a and d, we get 7 plus n minus 1 into 7 by 2 is equal to 84. And from this we can write n minus 1 into 7 by 2 is equal to 84 minus 7, that is 77. And n minus 1 is equal to 77 into 2 by 7, which is equal to 22. And n is equal to 22 plus 1, which is equal to 23. That is, the number of terms in given arithmetic progression is 23. Now, sum of these 23 terms is Sn is equal to n by 2 into a plus l, because we know the value of l here. So Sn is equal to n by 2 into a plus l. Now substitute n is equal to 23, a is equal to 7, and l is equal to 84. Now the sum of 23 terms, that is S23, is equal to 23 by 2 into a plus l, that is 7 plus 84. So 23 by 2 into 91, and is equal to 2093 by 2. This is sum of the given arithmetic progression. Now take the second one, 34 plus 32 plus 30 up to 10. So we have to find the sum of this arithmetic progression. So in this progression also, we don't know the value of n. So we need to find the number of terms. So before that, the first term in given progression is a is equal to 34, and the common difference d is equal to 32 minus 34, which is equal to 2. And let the number of terms in given progression be n. Now, as the number of terms in given progression is n, then 10 is the last term, that is an is equal to 10. So that is a plus n minus 1 into d equal 10. And now by substituting a is equal to 34 and d equal to minus 2, we get the value of n like this. So we get the value of n as 13. That is, we have 13 terms in given arithmetic progression. And we know the formula that Sn is equal to n by 2 into a plus l. So sum of 13 terms is S13 is equal to 13 by 2 into 34 plus 10. That is 13 by 2 into 44, which is equal to 13 into 22, and is equal to 286. So sum of the given arithmetic progression is 286. Take the third one, minus 5 plus minus 8 plus minus 11 up to minus 230. So this is also like previous problem. So I am just presenting the problem and I am not explaining here. Just watch carefully and understand yourself. Okay, students, please watch carefully each step. We got n is equal to 76, and now sum of n terms is Sn is equal to n by 2 into a plus l, and by substituting all values we get S76 is equal to minus 8930. Okay, so let us take the third problem in this exercise. In NAP, first one is given A is equal to 5, D is equal to 3, AN is equal to 50. Find N and SL. So in arithmetic progression, first term A is equal to 5, common difference D is equal to 3, and we need to find and also given nth term is 50. Using this hint, we can find the value of n, and after that we can find Sn. Okay, so it's given that An is equal to 50. As An is equal to 50, A plus n minus 1 into D is equal to 50. And now we can substitute A is equal to 5 and D is equal to 3 in this equation. And from this, we can write n is equal to how much? N is equal to 16. That is, we have 16 terms in given arithmetic progression. That is, n is equal to 16. And now Sn is equal to n by 2 into a plus l. As we know that nth term, that is the last term in given progression, we can use this formula. So whenever we know the value of L or An, we can use the formula to find sum of n terms is n by 2 into a plus n. So now by substituting n is equal to 16, a is equal to 5 and d is equal to 3, we get Sn is equal to 440. So n is equal to 16 and Sn is equal to 440. Okay, students. Take the next one. Given A is equal to 7, A13 is equal to 35. Find D and S13. So here we know the values of first term and 13th term, and using these two we can find D, and after that we can find S13. Okay, so in given arithmetic progression, first term A is equal to 7. Let the common difference of given AP be D. And now it is given that A13, that is 13th term, is 35. And we know that A plus A13 is A plus 12D. So we can replace A13 by A plus 12D. Now we have A is equal to 7. So by substituting A is equal to 7, 7 plus 12D is equal to 35. That is 12D is equal to 35 minus 7, that is 28. So that D is equal to 28 by 12, and by dividing 4, we get 7 by 3. So in that way, we got the common difference D as 7 by 3. Now S13. S13 is sum of 13 terms. And we know that the 13th term here. So we can use formula Sn is equal to n by 2 into a plus l, where n is equal to 13, a is equal to 7, and the last term A13 is 35. So now sum of 13 terms is 13 by 2 into 7 plus 35, which is equal to 42. And by simplifying this one, we get 273. So the sum of 13 terms is 273. And now the required values are D is equal to 7 by 3, S13 is equal to 273. Take the third one. Given A12 is equal to 37, D is equal to 3, find A and S12. So here also we need S12 and we know A12. So we can use n by 2 into A plus L here. So before that we have to find A. So in given arithmetic progression, common difference D is equal to 3, and it's given that A12 is equal to 37. And we know that A12 is A plus 11D. So we can substitute A plus 11D in place of A12. So A plus 11D is equal to 37, and A plus 11 into 3, because we know that D is equal to 3. So A plus 11 into 3 is equal to 37. And from this, we get A is equal to 4. And now we have A is equal to 4, D is equal to 3, and N is equal to 12, because we have to find S12 here. So by substituting these values in this equation, S12 is equal to 12 by 2 into A plus L, 4 plus 37. That is 6 into 41, which is equal to 246. So sum of 12 terms is 246. So that A is equal to 4 and D is equal, S12 is equal to 246. So take the fourth one. Now it's given that A3 is equal to 15. Third one, sorry. A3 is equal to 15. S10 equal to 125. Find D and A10. So students, here A3 is given. A3 is 15. That is A plus 2D is equal to 15. From this, we can write that 2D is equal to 15 minus A is equal to 15 minus 2D. Take it as equation 1. And also it is given that S10 is equal to 125. And students, we know that Sn is equal to n by 2 into 2a plus n minus 1 into d. So now S10 is equal to 10 by 2 into 2a plus 10 minus 1 into d. Okay. So we have 2 5s are 10. So 5 into 2a plus 10 minus 1, that is 9d, is equal to 125. From this, we can write 2a plus 9d is equal to 125 by 5, which is equal to 25. So now substitute A is equal to 15 minus 2d, because from equation 1, we have A is equal to 15 minus 2d from equation 1. And for this implies we can write 30 minus 2 to the 4d plus 9d is equal to 25. That is 5d is equal to 25 minus 30, which is equal to minus 5, and d is equal to minus 5 by 5 equal to minus 1. Now substituting this value in equation 1, we get A is equal to 15 minus 2d, that is d equal to minus 1. A is equal to 15 plus 2, that is 17. So we got the value of A. Now we require A10. A10 is A plus 9d. So we have both the values of A and D here. So we can find A10. A10 is equal to A plus 9d. That is 17 plus 9 into minus 1, which is equal to 8. So students, we have D is equal to minus 1 and A10 is equal to 8. Okay, students, that's all for today. And next class, we shall solve some more problems regarding to sum of n terms of an arithmetic progression. Until then, see you. Bye.